Example 8, find sine theta and cosine theta given that tangent theta is 4/3 and theta is in quadrant 3. Okay? So, to me, the easiest thing to do is draw a picture. Okay? It's not the only way. You can do it algebraically if you want using the Pythagorean identities. But for me, when they describe a picture, I like drawing a picture. So if I'm looking at theta in quadrant 3, what they've done is they've basically defined a right triangle. Okay? And since tangent is y over x, I'm looking at the y number and the x number as 4 and 3. Okay? Now technically, what I would do, since I'm in the third quadrant, I would know that x and y are both negative. I would put negative 3 and negative 4 there. Okay? So we want to find the r value. And so to me, you could either use this formula, remember this one, x squared plus y squared, or you could use Pythagoras. Well, let's use this one because we haven't seen it today, I don't think. Okay, so x squared, that's going to be 9, and y squared is going to be 16. We got square root of 9 plus 16, it's square root of 25, which is 5. The r value is 5. And you're going to see a 3, 4, 5 right triangle a lot in this class, so it will be advantageous for you to memorize that. It's going to be a 3, 4, 5. Okay? So as soon as I see that, I ought to be able to get we're going to sine theta. Sine theta is y over r, right? Y over r. The y value was negative 4 because it's downstairs, and r was 5. Then we also need cosine theta. Cosine theta is x over r. X over r, that's going to be negative 3/5. Honestly, I think that's the easiest way to do it. That's not the only way of doing it. I suspect the person who wrote this question wanted you to do this algebraically. So I'm going to show you. I just think it's a lot easier to do it drawing a picture. Okay? I'm going to do it this way quickly. They gave me tangent theta in this problem. And so if I was going to do it algebraically, I would use my Pythagorean identity that has a tangent. Tangent squared theta plus 1 equals secant squared theta. Okay? So if I'm plugging that in, I'd have to square it. Square that tangent, you get 16/9 plus 1 equals secant squared theta. Okay? Adding fractions, I would need a common denominator, so change that 1 into 9/9 and add together, you get 25/9 equals secant squared theta. If I'm going to isolate, I'm going to have to get rid of the squared, and so we'll take the square root, actually the plus or minus root. Okay? So plus or minus root is going to be plus or minus 5/3 equals secant theta. But here's where you have to understand where we are. We're in the third quadrant. Okay? Third quadrant. Third quadrant. And all students take calculus. Tangent and cotangent are positive in the third quadrant. That means secant is negative. Okay? Secant theta must be negative 5/3. Okay? We're in the third quadrant. Now that's not what they asked me for. They wanted to know sine and cosine. Okay? Sine and cosine. Well, I can get cosine because I know cosine theta is just the reciprocal of secant theta. So there's 1, there's cosine theta. Okay? Now, if I wanted to know sine theta, I could do a couple of different things. I could do maybe a quotient identity or maybe another Pythagorean identity. If I did sine squared theta plus cosine squared theta equals 1, I just plug in this cosine. Cosine theta is negative 3/5, so square root, that's 9/25. I have sine squared theta plus 9/25 equals 1. And so I'm going to solve. I'm going to subtract 9/25. But in order to do so, I would need a common denominator, so let's change that to 25/25. When you subtract, you're going to get 16/25. Sine squared theta equals 16/25. Take that square root, it's actually plus or minus. You're going to get sine theta equals plus or minus 4/5. Okay, now remember, we're in the third quadrant. That's downstairs, and I know sine theta is negative down there. So that's negative 4/5. There's your answer. Now, I can't imagine anybody in here likes doing it that way better than drawing a picture. But you could, you do need to know how to do both ways. All right? You got the same answer.